So, why are we doing this? Why are we doing covariate adjustment at all? Right? There's even like confusion on this point, I think, in the literature. I mean, why bother running a regression after? Why bother doing post-application blocking at all? And the reason is in a finite sample, your covariates may be imbalanced. And you think what that means is in a finite sample, your potential outcomes are imbalanced. So why is that bad? Well, the thing that most people agree on is, well, that might reduce the precision of your estimates. Right? So if more men got assigned to treatment than control just by chance, and gender predicts the outcome, I might get some extra noise that I don't want. But the other thing that's happening in that example that's often underappreciated is you might get conditional bias. Well, how can an experiment be biased? Because that's what's supposed to be, experiments unbiased. And what's going to happen when we think through bias and we think through variance, what's going to end up happening when you talk about the properties is what's the counterfactual you have in mind. Right? A lot of statistics is about a thought experiment, about what didn't happen. Right? So it's very metaphysical in that sense. So bias is about what would have happened if I reran the randomization again and again and again, and on average I'd get it right. Right? What conditional bias says is, oh, if I had more men than women in treatment, right? What would happen over randomizations that had the same covariate distribution, right? And you can see that if gender predicts the outcome, that may induce conditional bias. The conditional in that kind of randomization, you're going to have a biased estimate. So some people, like a Bayesian statistician, doesn't like that. Well, what a Bayesian statistician would say is, oh, if you have that kind of covariate distribution, you have too much error. You have increased mean square error, and then that becomes a precision issue. But either way you think about it, it's a pretty bad issue. This happens in the medical literature, mostly for rare diseases, right? If a disease isn't rare, then you probably don't even care about conditional bias, right? Because then the thought experiment is being played out, right? Yeah, there will be 20 experiments, right? And if one ends up being a little skewed that way, and the other one ends up being a little skewed the other way, that's fine, because on average it's going to work out. Where it plays out in the medical literature for rare conditions, there aren't going to be another 20 experiments. This is it for the next 5 years. Now, if someone says, yeah, but we're two statisticians. One of us shot to the left by 10 feet, the other one shot to the right by 10 feet. We nailed that elephant, right? That doesn't work anymore because you only have one draw. And then people start worrying a lot more about conditional bias, right? Who, given the draw that ended up happening, this would help over, right? So it sort of depends what decision-making thing you're worried about. In the social sciences, we just don't have that much density. So it's not like we're going to get usually 20 experiments in the same setting, on the same thing. So maybe we should worry about conditional bias more than some. It's like if they can get out the vote experiments in the US, for example, I'm not worried about conditional bias. Well, and I'm leaving off the fact that sample size is just so large. You don't have to worry about it anyways. But those are the reasons we worry about it. And the one that most people mention is the imprecision